here's a basic outline of what I was going to try and talk about today. Is really sort of the background and benefits to the renewable heat incentive. Then I'll highlight the sort of the application process, what you sort of need to do, what boxes you need to tick in order to get RHI. I'm assuming a sort of a little bit of a background knowledge of vaguely what's going on here. But if any of you sort of, well, what is all this about? Give us a shout. Then looking at monitoring and performance, how well is our bits of kit doing? How can we make sure that what is put in is actually delivering what we want and keeping all our tenants happy? And then last couple of slides will be looking at community-based renewables projects, how we can start to develop large-scale projects and what are the ways of doing it. So background and benefits. So obviously it's been mentioned in the context of John's discussion about looking to change the mix of the way we generate our energy. Number of targets, either the government has set itself or EU has introduced for us to try and achieve. But in the particular context of this one, the 2020 ambition is to have something like 12% of our heating coming from renewable sources. And that means many of the technologies that are covered under the RHI. So that'll be the biomass, that'll be heat pumps, that'll be solar thermal, that kind of thing. Now, in the good old past, the government provided lots of grant programs for us to put these sorts of bits of kit in because they're not exactly cheap. And at the time were pretty innovative bit of kit as well. They were being developed. So these grants sort of enabled you to put these technologies in reasonably cost effectively. And you had things like the low carbons building program, which BRE managed in the dim distant past, and there's been various other similar schemes run by us and also non-government. And in particular, the low carbons building program, which finished about 5 years ago, resulted in something like £100 million worth of funding and basically managed to enable something like 10,000 installations. So really quite reasonably large scale of operations, if you like. But it also gave it the industry sort of a big of a leg up, a bit of an opportunity to develop it and get a sort of a viable supply chain together. Now, grant programs are gone, more or less, and so you've got things like FIT and RHI, FIT, feed-in tariff, RHI, renewable heat incentives. So the FITs is basically to do with PVs and that kind of thing. And that was introduced in April 2010. So it's been running for quite some considerable time. So we've got quite a lot of experience of what that has managed to achieve. And then we've already had part of the renewable heat incentive. You may not be aware of it, it might not necessarily have been in your radar, but that was mostly to do with the non-domestic sector. So looking at large-scale bits of kit like district heating, perhaps industrial-sized heat pumps, mostly for larger buildings rather than from the domestic side of things. And so that brings us right up to date with the domestic RHI, which has been delayed for some considerable time, and a lot of research undertaken by DEC to make sure it got it all right, to make sure that the market was there, to make sure that the level of payments, because at the end of the day that's what people are interested in, how much money am I going to get, make sure that they pitch that right and not sort of have an overheated market, because certainly FITS was really did take off like a rocket. And what they're looking at the domestic RHI to do is to make a significant contribution to that target up there. And in particular, having a focus on off-gas properties, because we're looking at sort of electrical devices like heat pumps and also looking at biomass boilers. So, I think the main point to take from here is how much of an impact FITS has had. This is basically monthly data from right at the beginning of time, when there was only probably about 1,000 or so, 2,000 or so installations, and you can see a huge growth over the next 4 years of electrical-based renewables technology. Probably can't read this too well. Your eyesight is anything as bad as mine, but you see all these purple bars, that's all the PVs. So whenever you drive up and down estates now, you can see PV panels emblazoned all over roofs, and this is basically what's driven that. You know, you can start arguing over the aesthetics of whether you like that kind of thing on your roof and whether it adds to your property or not, but at the end of the day, it's had a heck of an impact. So that might be something that we could look at as far as RHI is concerned. As I said, we've already had phase one of RHI, and that's the non-domestic version of it. And this pie chart is just giving you an idea of how much stuff has gone in. So here you've got a pie chart showing you the total numbers. It's around about 4,000 installations have gone in over the last, about 3 years or so. And you can see it's basically dominated by biomass, massive amount of biomass below 200 kilowatts. And then you've got a reasonable size lump of medium-sized biomass. The heat pump side of things, which is what I'll talk a bit more about, is actually fairly small beer. So it's all these biomass boilers that are going into these large buildings, which is what's basically driving, which RHI is driving. So back to the sort of issues that the domestic RHI is trying to address. I've already alluded to one, and that was this off-gas issue. But another one that might be of interest to you as RSLs is the fuel poverty issue. I'm not going to go into a huge amount of depth on this, but just to sort of draw your attention to it, you've probably all come across this 10% rule about fuel poverty. If you're spending more than 10% of your income on keeping warm, then you're in fuel poverty. But there's been a lot of issues about a bit of how crude that is and doesn't properly capture the dynamics of it, because some people might choose to spend an awful lot of money to keep really super toasty, and they are technically in fuel poverty. And you have this issue about people flipping in and out of fuel poverty as fuel prices rise and as they spend more or less on their heating. So you had the Hills Review, as it was known, and the general acceptance of trying to get a better definition of fuel poverty. And this is basically it. As I say, I'm not going to go into too much detail, but in essence, it's a relative scale, and it's looking at low-income, high-cost indicators. And if you're somewhere in this little box here, then you're basically defined as in fuel poverty. And the idea to get out of fuel poverty is to move from this position up to there, and that's basically the fuel poverty gap, if you like. And here's how fuel poverty has changed over the years under the new indicator. You might have seen other figures kicking around based on the old indicator. In very simple terms, this has tended to lower the amount of households in fuel poverty. But basically, we've still got a figure we shouldn't exactly be trumpeting from the rooftops. It's something like around about 10% of households are in fuel poverty. It's something like around about just about 2.18 million, I think. But it's predicted to rise in 2013, mainly due to the high energy costs. So fuel poverty is part of this drive, but there's also this issue of off-gas network. And this is data from DEC's National Energy Efficiency Database, NEED, and this is just showing you the amount of properties that are off gas as of 2011. I've broken it down by the tenures, and you can see in the local authority sector, actually it's generally a bit lower, but overall you've got something like around about, in that particular tenure, ranging from about 10 to 25%. And you've got some of the sort of the rural areas like the southwest is sticking out in particular. Another area potentially is the northwest as well, east of England, sorry, as areas that are off gas. Overall, something like 4 million properties out of the 20-odd million are actually off gas. And what DEC is looking for the domestic RHI to do is to target something like about 750,000 of that total over the next 7 years. And they've got a sort of an interim target of something like about 34,000 homes in the first 2 years. Basic maths means they're looking at doing something like around about over 100 a day. So the two previous slides have sort of brought together a little bit, because fuel poverty is often linked with being off gas. You've got these rural areas that haven't got the option of nice, efficient condensing gas boilers. They've got to use electrical heating systems, electrical storage heaters, or it may be oil burning. And this is a fairly recent map from the most recent fuel poverty report, so you can start to see the regional distribution of fuel poverty. And if you want to go into that report, you can actually start getting it down to lower super output areas. So it's got lots of clever whiz GIS stuff there if you wanted to have a look at. But at the same time, you can start to look at where we've got pockets of where there are off-gas networks. And you can start, you can go through it in detail, but you can start to see the links where some of the darker blue areas start to match up with some of the red areas where we've got off-gas. But of course, fuel poverty is a much more complex beast than just simply off gas. There are other factors as well in terms of the actual energy efficiency of the stock and the income of the people in that property, how they choose to heat it. So I'm not saying there's a big correlation there, but you can start to see the links and addressing the two together. So that's giving you a bit of a background to the whole concept of what's underpinning the domestic RHI, achieving renewable targets, addressing off gas, addressing fuel poverties, getting more efficient heating systems in. So, how are we doing so far? Well, some of you may have heard of the RHPP, Renewable Heat Premium Programme. It was basically a grant programme that was managed by Energy Saving Trust to try and get renewable heating technologies into buildings and into houses, sorry. And that ran from August 2011, about the time of the start of the non-domestic RHI, and continued up until just only a few months ago. And this gives you an idea of the sorts of bits of kit that have gone in under the RHPP. So quick totting up, it's something like around about 15,000 bits of kit have gone in under the vouchers claimed under the RHPP. And interestingly, unlike the non-domestic RHI, we're seeing heat pumps coming through very strongly. Air source heat pumps making up 40% of the total, and then you've got your solar thermal coming in as well, and then you've got your biomass boilers, and then more expensive ground or water source heat pumps. And those figures in brackets there, that's the size of the grant that was there. It was to help sort of bridge the cost of actually installing it. So overall, yeah, quite a popular programme that has generated quite a lot of installations, a lot of interest, and has helped, again, sort of push the industry along. And I'll come back to this particular programme in a few slides. How are we doing at the moment under the domestic RHI? Because, of course, RHPP is finished. As I say, this is very, very recent data. It's only been going for, I think it started something like about 6th or 7th of April. So you've got something like about 386 accredited installations. So that 100 a day that I talked about isn't being met yet. Having spoken to Ofgem, I think they've said they've had about 70 on a good day. Obviously, the idea is that it's going to ramp up. I suppose we're back in Green Deal territory here. It's going to ramp up. But I can see this certainly having more of an impact because it is actually money at the end of the day. And I'll come on to that, how much money am I going to get for all of this? So I think it is going to have the impact, but it is, at the moment, a slow start. But we really are only a few weeks into it. So, renewable heat incentive, what's it all about? So, I'm going to whiz through this. I'm not going to start going into gory detail. The best thing to do is to look at the guidance. But anyway, what's it all about? Already talked about it. April 24 it started, covers Great Britain. Stimulate the uptake of renewable heat, targeted at off-gas. Policy decisions by DEC, but it's managed by Ofgem. They're the guys that you have to do all the applications to, and there is parts of the website doing it. Right, how do you become eligible? It covers single domestic dwellings, open to all tenures, owner-occupiers and registered providers. It's not available for new build properties unless you're a self-builder. You're also allowed legacy applications. So you don't necessarily have to have had installed the kit from now onwards. It could have been something you installed a few years ago. In fact, anything since 15th July 2009, you're allowed to apply for. What technologies does it cover? Well, I've already sort of shown you, intimated at it. Biomass, wood fuel boilers, and stoves, pellet boilers with integrated boilers for space heating. ground to water and air to water heat pumps, and solar thermal panels. Not covering things like integrated PV type things and not your sort of biomass stoves. Picking up the point on legacy applicants, yes, going right back to July 2009. Also, if you had RHPP vouchers, you're allowed to apply as well. But what they've done is they've sort of phased it to stop all these people that have already had some money, suddenly a big swamp of applications that are going to slow up all the current applications. So if you receive RHPP vouchers, then they're phased depending on when you received your voucher. So over the next few months, I think the first wave can start to apply now, and those involved in the last phases of RHPP will be able to apply in a few months' time. But you've got to do it by the end of this financial year if you're going to get your money. And as well as the RHPP, the phasing, you're not going to get the full amount because you've already received your £800, your £1,000 from the RHPP voucher, so that will be factored into the award you get under the RHI. Other requirements, perhaps no great surprise there, systems and installers certified under the microgeneration certification scheme, and the systems need to be on the Ofgem's eligibility list. You've got to have a Green Deal assessment, and this includes people that had them installed in the past and from now on. Basically, as far as that is concerned, we're looking at trying to have, making sure that the house that you're putting your kit in has a reasonable level of fabric performance, something he did, I think John's mentioned this already, rather than just having the eco bling to sort yourself out, make sure you've got something that is reasonably thermally efficient. And so the EPC that would support the Green Deal assessment might have a recommendation to do cavity wall insulation and loft insulation. And so you've got to put that in if that's on the EPC report. Now, there may be exemptions to that. For example, you could be in a driving rain area. It could be that you're in a conservation area, and there may be other planning constraints that would mean that you can't do that. But those are the only exemptions that you're allowed to wriggle out of that loophole. If you've got possibly hard to treat cavities, then they might start steering you towards eco funding in order to bring the house up to the relevant standard before you can start to put your RHI, before you can put your heat pump and claim your RHI. You also need to submit the heat pump seasonal performance factor. That comes from UMCS calculation. They have a process they go through to give you an overall performance factor for it. Now, one of the things about the non-domestic RHI is you have to meter. You actually have to measure the amount of heat that you're generating. For the domestic RHI, you don't generally have to do it, which is an advantage in terms of cost in one way. But there are exceptions to that. These are the criteria where you have to meter the bit of kit. One is if you have a backup heating. In other words, you might have another renewable heating system. You've got your biomass boiler as well as your heat pump, for example. If you have another boiler that's operating, but that's providing space heating, then yes, you've got to do it in that case as well. But if it's just something that's operating in a single room, then you're all right. Another reason, if you're using a biomass that isn't designed to heat the whole property, and also if the property is only occupied for half a year or less, then again, you've got to do the metering. So, particular responsibilities for landlords. This is where I sort of demonstrate basically for the lifetime of the tariff, and I'll come on to that in a moment, as to what requirements you need to do. You need to continue to own the heating system. Some of this is fairly obvious stuff, but just to sort of bring it out, bring it to the fore. Heating system is in good working order. It needs to be working for that whole period of which the tariff is being paid. There needs to be, if there's any changes to the heating system, then that you need to notify about that. If there are any changes in the circumstances that affect your eligibility to receive payment, so there might be a change in occupancy. There was that half a year that the building's got to be occupied. If that changes, then you need to notify that. If you receive funding from other sources, then again you need to notify, because that might affect the tariff. Here's to do with another issue to do with which fuels are you allowed to use for the biomass systems, looking at the emission certificate that would come from HETAS. The other thing is to make sure that you are managing it all properly and operating due diligence. So you can provide them with relevant documents. That might be the MCS certificates, it might be the Green Deal assessments. If you've been overpaid for whatever reasons, because there's been changes of circumstances, you've got to pay that back. And if needs be for the purposes of inspection and auditing, you need to be there facilitating access to tenants' homes, for example. And you've also got to provide annual declarations about heating systems, which in some ways ties all of this up together. So those are the extra responsibilities. So not too onerous, but it's a case of just making sure you keep on the right side of Ofgem if you want your money. Talking of money, what do I get? Those are basically the tariffs at the moment, pence per kilowatt hours, for air source, ground source, biomass, and solar thermal. The basic rationale in generating them, the DEC commissioned lots of work, done lots of clever economics of trying to understand the market and what the costs were for installing this as opposed to other forms of heating. And the idea is that it should compensate for the difference of installing these sorts of fuels, these sorts of technologies, to the more traditional one. They're based on 20 years of heat produced, so you're going to have a lifetime of this bit of kit for 20 years, it's assuming. Interestingly, the actual payment is over a period of only 7 years. So you get 20 years worth of heat paid in 7 years. And that's paid quarterly. So each quarter you get your money. So that sort of tariff might be getting you something like about £800,000 a year. So quite a lot of money. Already mentioned about fossil fuels costs, are those factored in by households off gas grid. Again, going back to this point of looking at those householders off gas grid. And then you've got some clever economic word there about the process by which they manage the budget. It's called digression. What that in essence means is that the tariff that you get there you will keep for the lifetime of the 7 years, but in future applicants, there's only so much of a pot of money, so they'll continually review it every quarter, and so if there's less money in the pot, then it will go down. But that level that you then come in at will be maintained. So if you get in early, you're going to get those sort of tariffs, but if you get in, say, about 2 or 3 years' time, you might find that you don't get quite the same level. So that's the digression process, as I said. There's probably a lot more clever economics, but it goes way over my head. As I said, the payments are quarterly for a period of 7 years, and it's based on a deemed amount. That's where they've used the calculation processes within the Energy Performance Certificate or within the MCS process. So for each of the technologies, biomass, heat pumps and solar thermal, that's the deeming calculation that's done that tells you what the kilowatt hours is, and then you just apply your tariff to that. So, metering and performance. As I said, you don't have to meter under the domestic RHI. If you do have to meter, you can just be, they'll install a simple heat meter and then it's up to you to write down the relevant figures and then submit it through the Ofgem process. It's my RHI or something like that on the Ofgem website. But what you also got, for the more technical minded, is these so-called metering and monitoring service packages, MMSPs. Where it's a little bit more technical and a bit more useful, getting some data out of it. So, aside from the mandatory requirement for metering, what's the upsides for doing some sort of proper metering? Well, are you actually going to get the specified performance? As I said, your level of performance is based on a deeming calculation, which has the usual assumptions behind it and doesn't allow for whether the bit of kit was put in properly, has the person used, has the tenant used the kit properly? Because that's one of the things that can be difficult for people that use, for example, heat pumps and micro CHPs, is they think they're just ordinary boilers. So they're just turning them off and on, turning them off and on. I heard stories only yesterday about some people that were just turning micro CHP systems off and on, and they were broken within the year, rather than just letting them go on. For things like heat pumps, they're a sort of continual low temperature source of heat, so they're best left just to carry on rather than being turned off and on. So that can lead to a diminution in performance, as well as them not being put in properly. Is it providing adequate heating for tenants? Are they achieving the temperatures that they want when they want them? So this is where metering will actually help you see that. And it's also a useful tool for diagnosing problems and planning maintenance for the heat pump, because obviously by having the sorts of metering, and I'll show you the sorts of results you can get, it's a very useful diagnostic tool to tell you that something's not quite right with the kit. Putting that bit of kit in does cost money, but they'll pay you for it. In exactly the same way as that you get paid for the heat that you generate, you also can get paid for putting these bits of kit in. But basically, it's heat meter. Sometimes you have to put more than one heat meter on. We've been doing some work where it's not just the space heating, they're heating their swimming pool, so they need to have a second heat meter for that, but hopefully you've not got too many houses where you've got a swimming pool on as well. Electricity meters, again, it may just be one, but depending on the complexity of your system, you might need to put more in. Temperature sensors to measure flow and return from the system, but also measuring ambient air temperatures as well. Then a logging device to actually collect the data. Usually the data has to be collected on a 2-minute interval, every 2 minutes. And then PC with data viewing platform. You've got to be able to see that information. And you've got to tick all those boxes in order to get your money. And there is some guidance on how to do that. So yes, it's a case of having, I think it's on the next slide, a case of having suitably qualified MCS installers to actually put this bit of kit together, and they need to offer these packages that meet all of those requirements because they're quite demanding. At the moment, there isn't really anybody that's has a commercial offering to market yet, but there will be, I would imagine, quite soon as people start to pick it up. As I say, the whole RHI has only been started since April. It's got to operate for the life of the tariff if you're going to continue to get your money, and you must be able to log up to 75% of all possible data. So you can't have long data blackout periods with your information. You've got to log up to 75%. And in theory, that data must be accessible by DEC or Ofgem. Having spoken to them, they probably won't be demanding this left, right and centre, but they need to have that right to be able to say, yeah, I want to see your data. When do you apply? Well, you can apply at the same time. You put your heat pump in or your biomass or whatever, or you can do it afterwards. But if you leave there, if you, let's say, let your bit of kit run for a year and don't put the metering until after that time, you'll only get the 6 years' worth for the meter. And the clock starts from when you put the heat pump in or the biomass pellet boiler in. Okay? It's a simple questionnaire that you need to submit to Ofgem because they need to be satisfied that the MCS installer is registered with them and they've got a viable package, and you may be subject to audit, but then that's the same with all of this. Overall, they reckon they might be offering sufficient money to do 2,500 packages in the first year and 10,000 per year after that. So in theory, if the heat pump and biomass numbers are anything to go by, there is sufficient budget to do something like about a third of these things could have these packages on if people decide to take it up. What will it look like? Well, here's the sort of kits. You've got temperature sensors, you've got a heat meter, electricity meter, and then this is a sort of a fairly typical air source heat pump. And then you put your various meters on there. And we're actually doing a project, might be interested to know, for DEC through the Energy Saving Trust, where we're monitoring something like around about. This is the type of data. I'm not going to start going through this in boring detail. You probably can't see it too clearly, but here you've got the heat output, you've got the electricity output here, and you can start to see basically the performance factor is basically the heat divided by the electricity. So you've got something like around about, here we go, something like around about 2.5 for the electricity, and around about 8 to 9 tops for your heat output. So there's your 1 to 3 factor. So we're getting a seasonal performance factor for this particular heat pump of about 2.5 to 3, but it's varying over the course of this 2-day window. So you're actually seeing how this seasonal performance factor is changing every 2 minutes, and these are the temperatures. So lots of clever kit, but at the end of the day, you'd be more interested in but that's the useful diagnostic tool that we've got. As I say, we're doing a big project for the for DEC where we're actually monitoring 700 heat pumps, ground source and air source heat pumps all over the country, both in the owner-occupier sector and the RSL sector. And this is some of the preliminary results that DEC has published for them. This is just for 1 month's worth of data that they've aggregated up to a year. And this is the sort of performance factors that we're seeing for these air source heat pumps. You've got anything from around about 0.4, so pretty poor, to something around about 4. So you've got a very good performance factor. Typically, you hit around about here for air source heat pumps. So they're not doing too badly. All these numbers, by the way, are individual site references, so don't worry about them too much. Some of you may remember that the Energy Saving Trust did their own field trial some years ago on heat pumps. And this was the type of performance that they got. So you can see that in the, say, 2 or 3 years since that time, the industry actually has improved. We're now pushing this performance over to the right, which is obviously what we want to do. My left, your right. And you can start to see that we are getting somewhere. But obviously, if you're getting factors down here, you're probably not going to be happy bunnies. You paid good money to have a heat pump put in. So this is where the monitoring will be very useful to start to tell you that there is something wrong there and you need to start to get your installer to come back in and work it out. Well, unless there's some other issue there with the metering, but generally this is genuine performance factors, so there are some issues there. Is it something to do with the installations not being put in right? Is it that the householder is using the heat pump in completely the wrong way? So here you've got, this is your average performance factor, 2.34, and under phase 1 it was 1.84, so that's just reiterating this point about how much better it is now. And this is this seasonal performance factor of 2.5 greater than, that's a crucial figure because that's the energy, that's the Renewable Energy Directive from the EU is saying you can only characterise something as being renewable heating if it's going to get a performance factor greater than 2.5. So that's what's of interest particular to the government. Similar thing for ground source heat pumps, not going to go into too much detail, but again you can see the shift in performance from the EST field trial. You've got slightly better seasonal performance factors under the new programme. But again, there are some real laggards here that would need addressing if you were starting to get that sort of information on your own heat pumps. And then this is a useful tool for being able to say what sort of improvements you're getting. So here, what this table is doing is saying, previously, the heating system that was put into these homes, LPG, electricity, oil, and so on and so forth, and these are the efficiencies of these heating systems. What it's saying now is that having, whether you're going to make fuel bill savings as a result of putting either air source heat pumps in or ground source heat pumps in, and in 92% of cases where there was LPG, you are going to make fuel bill savings. Actually, in many cases, you're doing well. You're making, in significant cases, you're making savings when you've done these replacements. But of course, that is assuming that the householder uses heats the house in the same way. There may be thermal comfort issues here, which doesn't come into this particular analysis. But it gives you an idea that, in this case, lots of heat pumps have done some pretty good improvements. Coming to the end now, Just a bit of shameless plugging now, if you like. A couple of BRE publications I was just going to push. What this slide is trying to show is that putting renewable heating in isn't cheap. You do get your money back over that period with the tariffs, but it's the upfront cost of capital that's an issue. And what this graph is trying to show here is sort of a summary of the various models by which you might wish to fund large-scale renewable energy projects. You sort of start from the left, where it's sort of it's the rent-a-roof model that's been used widely for PVs. Third party, they have all the problems. You get your electricity, but they get the tariff, they get the hassle of putting it in and maintaining it, etc. So you're going from one extreme of not much involvement, minimal risk, or hopefully minimal risk, to the other extreme where basically you do it yourself. You've got in-house reserves, you pay for it, you're responsible for it. So those are sort of the two extremes that you've got. But here you might look at sort of intervening models which have been developed potentially under the FITS umbrella of having leasing or special purpose vehicles where you encourage private equity bank money in order to basically provide you with that upfront funding. But obviously you've got to pay them back. They might have a 8, 9, 10, even 12% return on investment they're looking for. So you've got to pay that back. But hopefully, with some of these models, you do get ownership of them after, say, like a 10-year period. So that's the sorts of approaches you might want to look at if you want to sort of jump on the RHI bandwagon. These sorts of, as I say, models are being developed. Ofgem is certainly looking at trying to make sure that there's adequate consumer protection. But if you want some more details, there's a document for you. And then the other one, another shameless plug for another BRE report that colleagues of mine have done in the light of when they did manage the grant-based programs for renewable energy. There were some lessons learned, and I think it's useful. In some ways, it's not necessarily probably anything too astounding to you guys as asset managers as to what needs to be done. But it's just a useful sort of aide-memoire as to the sorts of issues you need to address if you want to make sure you don't get disappointed by your renewable energy project. Community engagement, make sure you bring everybody on board and they understand what's going on. Site survey and briefing, make sure that you've done an adequate site survey. Have you put the right bit of kit in? Does everybody know what's expected? Equipment selection, making sure that you use properly eligible bits of kit and it's going to do what it should do. Project management, basically you might be dealing with multiple contractors, electricians, plumbers, etc. It's trying to coordinate those guys because often you can get this sort of tension as one trade follows another and causes subsequent problems. Handover and training, especially I think this was found when you had multiple renewables coming in, you ended up with not having at all the right sort of handover process. People were none the wiser as to what sort of kit that they were using. In this instance, it's a good idea to have a champion here that sort of goes away and really immerses themselves in understanding how the bit of kit works and is there to work with tenants to advise them on how they can use the bit of kit effectively. And obviously having an adequate operation and maintenance regime, and this is where the Monitoring Act side of things will be very useful to diagnose it, to make sure that your bit of kit continues to deliver for the lifetime of the project. So, to finish, a few key points. It's a great opportunity to replace expensive old bits of kit and potentially also improve thermal comfort. There is high upfront costs, but the tariffs are there to help make it more cost effective, and indeed there is sufficient, there's some good rates of return that you've got there. But obviously that high upfront cost is a barrier, but there are funding opportunities from private investors. I suppose it goes without saying, look at all the Ofgem guidance. I've whizzed through it very quickly. There's a lot more detail there for you to sort of absorb, and it's all on the Ofgem website. Main thing is to work closely with all stakeholders, tenants, installers, product manufacturers, maintenance teams to avoid disappointments, but hopefully that's all bread and butter to you guys already. And consider installing monitoring equipment to diagnose problems. As I've said, it's very useful to find out where your bit of kit's going wrong, and it's not, the old cliche doesn't do what it says on the tin. But it's also very useful to identify any tenant issues. Are they, I'm cold, it's not working, I'm not happy. So, I'm going to say another shameless bit of plugging for ourselves here is that if you're interested, we've got the kit that can enable you to monitor your own installations. There we go. Thank you.